Have you ever wondered how the water flowing into your home gets there so cleanly and reliably? A big part of the answer lies in the pipes that carry it, but how are these seemingly simple tubes actually made? Today, we're diving deep into the fascinating world of water pipe manufacturing. From ancient clay pipes to modern, high-tech materials, the journey of the water tube is a story of innovation and engineering. Stick around because you'll never look at your tap water the same way again. Let's start with a little history. The earliest water pipes, used by ancient civilizations like the Romans, were made from lead, stone, or clay. While revolutionary for their time, these materials had their drawbacks. Lead, as we now know, is toxic, and clay pipes were brittle and prone to breaking. Over centuries, we experimented with wood and cast iron, which were stronger but also had issues with rust and contamination. It wasn't until the 20th century that we saw a real revolution in water pipe materials, leading to the safe and durable options we have today. So, what are modern water pipes made of? The answer is surprisingly diverse. The main players in today's market are plastic, copper, and various types of steel. Each material has its own unique manufacturing process and is chosen for specific applications based on its properties. Let us start with the most common type you'll likely find in a modern home: plastic pipes. When we say plastic, we're usually talking about a few different types, primarily PVC, CPVC, and PEX. PVC, or polyvinyl chloride, is the white plastic pipe you often see for drainage and cold water lines. Its manufacturing process begins with a raw material called vinyl chloride monomer. This chemical is put through a process called polymerization, where individual molecules link together to form long chains, creating the PVC resin. This resin looks like a fine white powder. To turn this powder into a pipe, it's mixed with various additives. These include stabilizers to protect it from heat and UV light, plasticizers to make it more flexible, and pigments for color. This customized compound is then fed into a machine called an extruder. Think of an extruder like a giant high-tech meat grinder. A large screw inside a heated barrel pushes the PVC compound forward. The heat and pressure melt the plastic into a thick, consistent liquid. At the end of the extruder is a die. This is a precisely shaped tool that the molten plastic is forced through. The die has a circular outer shape and a central pin, or mandrel, which creates the hollow center of the pipe. As the hot, perfectly formed tube emerges from the die, it's still soft and needs to be cooled down quickly to hold its shape. It passes through a vacuum sizing tank where water sprays cool the exterior while a vacuum helps maintain its roundness. After cooling, the long continuous pipe is cut into standard lengths, often by a flying saw that moves along with the pipe to make a clean cut without stopping the production line. Finally, the ends might be belled to create a socket for easy connection, and then the pipes are bundled and prepared for shipping. Next up is CPVC, or chlorinated polyvinyl chloride. It's a close cousin to PVC, but with an extra step in its creation. The base PVC resin undergoes an additional chlorination process. This involves exposing the PVC to chlorine gas and UV light, which adds more chlorine atoms to the polymer chain. This simple-sounding step dramatically increases the pipe's heat resistance. That's why you often see CPVC, which is typically a light yellow or tan color, used for hot water supply lines, while standard PVC is reserved for cold water. The extrusion process for CPVC is very similar to PVC, just at slightly different temperatures and pressures to account for the material's properties. Then we have PEX, or cross-linked polyethylene. PEX has become incredibly popular for its flexibility, making it easy to snake through walls and floors without needing a lot of joints. The manufacturing process for PEX is quite different. It starts with high-density polyethylene, the same stuff used to make milk jugs. The key is the cross-linking part. This process creates chemical bonds between the long polyethylene molecules, turning them into a three-dimensional network. This network structure is what gives PEX its amazing durability, flexibility, and resistance to temperature and pressure. There are a few ways to achieve this cross-linking. The Enyo method, or PEXA, involves mixing the polyethylene with a peroxide chemical before it goes into the extruder. The heat of the extrusion process activates the peroxide, causing the cross-linking to happen as the pipe is being formed. Another common method, the silane method or PEXB, involves adding a silane compound. The cross-linking actually happens after the pipe is extruded, in a secondary process where the pipe is exposed to steam or hot water. Regardless of the method, the result is a flexible tube that comes in long coils, making installation fast and efficient. Now, let's move away from plastics and talk about metal pipes, starting with the classic, copper. Copper has been used for plumbing for thousands of years and is still prized for its natural antimicrobial properties and extreme durability. The journey of a copper pipe begins at a mine where copper ore is extracted. This ore is crushed and processed to produce nearly pure copper cathodes. These cathodes are melted down in a massive furnace. To create a pipe, the molten copper is poured into a mold to create a solid cylinder called a billet. This billet is the starting point for the pipe itself. The billet is then heated until it's red hot and placed in an extrusion press. A powerful hydraulic ram forces the billet through a die, much like with plastic pipes. However, a piercing mandrel pushes through the center of the billet at the same time, turning the solid cylinder into a thick-walled hollow tube. This initial tube is called a bloom. The bloom is still too thick to be a final pipe, so it goes through a series of drawing processes. In a process called tube drawing, the bloom is pulled through progressively smaller dies. Each pass stretches the tube, making it longer and thinning its walls until it reaches the desired diameter and thickness. This process, known as cold drawing, also hardens the copper, making it stronger. Depending on the intended use, the copper pipe can be left in this hard temper or it can be annealed heated and then cooled slowly to make it soft and flexible again. The finished pipes are then straightened, cut to length, cleaned, and packaged. Finally, let's look at steel pipes. While galvanized steel was once common in homes, it's less so now due to rust issues. However, stainless steel and carbon steel pipes are essential for large-scale water transport, industrial applications, and infrastructure. There are two main ways to make steel pipes: seamless and welded. Seamless steel pipes, as the name suggests, have no welded seam. The process is similar to making seamless copper pipes. It starts with a solid steel billet. The billet is heated to extreme temperatures, over 2,000 degrees Fahrenheit, in a furnace. This glowing hot billet is then rolled and stretched, and a piercer creates the hollow center. It then passes through a series of rollers that precisely shape it into a tube with the correct wall thickness and diameter. Because there's no seam, these pipes are incredibly strong and are often used in high-pressure situations. The other method is welded pipe manufacturing. This begins with a flat steel sheet or coil, known as scalp. The scalp is fed through a series of rollers that gradually bend it into a cylindrical shape. Where the two edges of the steel meet, they are welded together to form a seam. The most common method for this is electric resistance welding, or ERW. High-frequency electrical current is passed through the edges of the steel, heating them to a forging temperature. Mechanical rollers then press the hot edges together, creating a strong fused bond without using any filler material. After welding, the pipe may go through additional sizing rollers and heat treatment to relieve stress and ensure uniformity. The weld seam is often tested using ultrasonic or X-ray methods to make sure it's flawless. So, from a simple powder or a solid block of metal to the finished product, the manufacturing of water pipes is a precise and highly controlled process. Each material, whether it's PVC, PEX, copper, or steel, has a unique journey that gives it the specific properties needed to deliver clean, safe water to our taps day in and day out. The next time you turn on your faucet, take a moment to appreciate the incredible engineering hidden within your walls. It is a testament to how far we've come in our quest for modern convenience and public health. Thanks for joining me on this deep dive into water pipe manufacturing. If you found this interesting, be sure to hit that like button and subscribe for more videos where we uncover the engineering behind everyday objects. Let me know in the comments what you'd like to see us explore next. See you in the next one.